Okay, chapter 7, section 3. We're going to be looking at how to name these ionic compounds and how to write formulas for the ionic compounds. And if you can do simple math, you can do this. Okay? If you can do simple math, you can do this. So let's look real quick at monoatomic ions. What does the prefix mono mean? One. Mono means one. So a monoatomic ion is an ion with one atom. Okay, monoatomic, one atom. So when you're talking about monoatomic ions, you have both positive monoatomic ions and you have negative monoatomic ions. So when I have a binary compound, what does the prefix bi mean? What number? 2. Prefix bi means 2. So mono's 1, binary is 2. So if I have a binary compound, I have 2 monoatomic ions that have to come together. One positive, one negative. Okay? All right. But one thing that we've got to establish before we are able to write these compounds is how to pick out the oxidation number. All right? There is a pattern. Periodic means pattern, right? Everything we've done in the periodic table, there is a pattern to that. All right? So let's look and see what the pattern is for oxidation numbers so that you'll know. And if you want to write this on your periodic table or jot it down somewhere if you think you can remember it, that's fine, but you've got to remember this pattern. So we go to the periodic table. Oxidation numbers are based on valence electrons. Okay? What was the pattern for valence electrons?
1, 2, skip the dip, 3, 4, 5, 6, 7, 8.
Good. All right, so this column has 1, on this column have 2, skip the dip, 3, 4, 5, 6, 7, 8. All right, so are the noble gases, are they normally going to bond? No, they are mostly unreactive. Their oxidation number is easy, 0. Okay, we're not worried about them with this. We're not going to deal with noble gases with this. We're worried about 1 through 7. Okay? Now, let me ask you this. If I have sodium, how many valence electrons is it going to have? 1. And what was the magic number of valence electrons that make an atom happy? 8. So is it easier for me to lose that 1 valence or gain 7?
Lose the 1.
Lose the 1. If I lose an electron, what's my charge going to be?
It's going to be positive.
Positive. How many did I lose?
1.
1. So my oxidation number is plus 1. Okay, let's go to the next one. If I have magnesium, how many valence electrons does it have?
2.
It has 2. Is it easier for it to lose those 2 or gain
6.
6? Lose 2 or gain 6?
Lose 2.
Lose 2. If I lose, how many, what's my charge, positive or negative?
Positive.
Positive, how many did I lose?
2.
2. So my oxidation number is
Plus 2.
plus 2. We're going to skip the dip. All right, let's go over here to aluminum. Aluminum's valence is
3.
3. So is it easier to lose those 3 or gain 5?
Lose the 3.
Lose 3. So if I lose, I am
Positive.
positive. How many did I lose?
3.
3. Now I know this seems like so repetitive, but I just want to make sure y'all get it, okay? So now I'm here at carbon. Carbon has how many valence?
4.
4. It's easier to lose 4, gain 4.
Either way.
I'm going to go either way, so I'm going to make this oxidation number plus or minus 4. Okay? All right. Nitrogen. Nitrogen has how many valence?
5.
5. Is it easier to lose 5 or gain 3?
Gain 3.
Gain 3. All right, so now if I gain, what's my charge going to be?
Negative.
Negative. How many did I gain?
3.
To be happy? 3. So my oxidation number now is negative 3. So if I have selenium, how many valence?
6.
6. So is it easier to lose 6 or gain 2?
Gain 2.
Gain 2. If I gain, my charge is
Negative.
negative. How many did I gain?
2.
2. All right, and bromine would have
7.
7. Lose 7, gain 1.
Gain 1.
And my charge would be
Negative.
negative
1.
1, because I gained 1. Okay? Now, there is an exception for one of these. You know, there's always the exception. What elements or element is going to be my exception? Anybody know? Well, helium does fit in because it's a noble gas and its outer level's full. It's only full with 2, but it's still full, so it's still 0. So my other option for my exception, hydrogen. How many valence electrons can fit in that first level?
1. Or 2.
2. How many does hydrogen have in that first level? 1. So it's halfway full, right? Okay, so hydrogen, we're going to say can be plus or minus 1, because it could either need to lose 1 or gain 1 to be happy. Okay, so hydrogen is an exception. All right, with that being said, look at your pattern. Plus 1, plus 2, skip the dip, plus 3, plus or minus 4, and then we start going back down. Minus 3, minus 2, minus 1, 0. Your life will be so much easier if you can remember that pattern, okay? Now, if you can remember the valence electrons and you know how to work it out and say, okay, is it easier to lose this many or gain this many? Am I going to be positive or negative? You can. It's going to save you a lot of time if you can just remember plus 1, plus 2, plus 3, and so on and so forth, okay? That's just going to make your life easier if you can remember that. All right, so let's go back to what we were saying about binary compounds. The cation is written first, and the anion is written second. Cation, what was a cation?
It's like Ca plus ION. I remember doing that.
It's positive because you have a positive ion. So cation is referring to the positive ion. So you write that first. Your positive ion is usually going to be your metal. Okay? And if you have an anion, what charge is that?
Negative.
Negative. A negative ion. So it's negative. You're going to be looking at as your non-metal. Okay? When you're looking at binary compounds. And then we're going to use the subscripts to show how many are in each formula. Subscripts, remember, are the little numbers. Like if I have H2O, that 2 is the subscript. Okay? All right, so let's look at how to do a binary compound. Let's say that I have magnesium and I have chlorine. So Ms. Brock gives you a problem and says you need to write the formula for when magnesium and chlorine combined. The first step, the first thing you need to do is you go to the periodic table and you look to see, okay, magnesium's number is +2, chlorine's number is -1, oxidation number. So I got +2 and a -1. So, now Ms. Brock's a visual learner, so I like to write things out where I can see. So if magnesium is +2, chlorine is -1, what do I want the charges to equal once I get done bonding? 0. Okay, I want it to be neutral. I don't want any charge. I want it to equal 0. If I put this magnesium atom together with a chlorine atom, let's just pretend these are separate atoms. I have one magnesium atom with a +2. I have a chlorine atom with a -1. If I combine those, would that equal out to 0?
No.
No. What do I need?
Another -1.
I need another chlorine. Does that balance out to 0?
Yes.
Yes. So now if I write the formula, I have one magnesium atom that has a +2 charge. And I have 2 chlorine atoms that have a -1 charge. So I'm going to write MgCl2. Does that make sense? Okay? And so now the next step is I need to name this. And if I'm naming a binary compound, and by binary I mean just two atoms, okay? I have a cation and an anion. I'm going to write the name of the first one as it is, and I'm going to write the name of the second one and change the ending to IDE. Okay? So let's do another one. Let's say that I have aluminum for my cation and oxygen for my anion. What's the first thing I need to do?
Go to your periodic table.
Go to the periodic table.
Look at their valence electrons.
Okay, I'm going to look at the oxidation number, which I get from the valence electrons. What's aluminum's oxidation?
+3.
+3, and oxygen's oxidation?
-2.
-2. All right, so aluminum is +3. Oxygen is -2. Do those balance out to 0?
No.
No, what do I need more of?
More oxygen.
I need more oxygen, more negative. So what can I put here to balance that out? Can I do this?
No.
No, I cannot do that because oxygen's oxidation number is not -1. So I cannot just throw that -1 in there. Oxygen's oxidation number is what?
-2.
-2. So if I'm throwing another oxygen in to balance it out, I gotta go -2. Does that balance?
No.
No. What do I need?
Add 3. And then -2 again.
All right, I need another aluminum, which gives me +6.
Then -2.
Then another oxygen that now gives me -6. Does that balance out to 0?
Yes.
Yes. So now I have what I need. How many aluminum atoms do I have?
2.
I have 2 aluminum atoms that each have a +3 charge. How many oxygen atoms do I have?
3.
3. So Al2O3. How would I name that? Aluminum oxide. Just change the ending to IDE. Okay. Any questions? All right. All right, so now let's go to polyatomic ions. What does the prefix poly mean? Multiple, many, okay? So when I say a polyatomic ion, that is an ion that has more than one atom. So that is what the chart is that I gave you. That is a chart of polyatomic ions, and that's what you're going to use for reference. And they all have special names. And you see in your chart, you see the name, you see the formula, and you see the oxidation number. Okay, so for each polyatomic ion on that chart, you see the name, you see the formula, you see the oxidation number. Now, when you write these, you cannot change the subscript that is in that formula. Okay, for example, sulfate is SO4. Well, if I need 2 sulfates, I can't add a 2 here because that would give me 42 oxygen and 1 sulfur. So I can't do that. If I need 2 sulfates, I have to use parentheses and say that is 2 sulfates because sulfate itself includes that 1 sulfur and that 4 oxygen. Does that make sense? So if you need multiple of any of these polyatomic ions, you have to write it in parentheses. Okay? Now, just for your sake today, if you are writing these out and you don't need multiple, but it helps you in your brain to organize it, even if it's just one and you want to put it in parentheses anyway, you feel free to go ahead and do that. Okay? All right. All right, if you see a polyatomic ion with 1 or more oxygen atoms in it, you would refer to that as an oxyanion. All that oxy mean is referring to oxygen. Okay? All right, So your rules for naming, and you should already have this in your notes, your rules for naming your ionic compounds. So your compounds between positive and negative ions, essentially metals and nonmetals. You're gonna name the cation and then the anion. The positive metal always comes first. Positive ion or the metal always comes first. We went over the monoatomic, how to name those and how to change the ending to IDE. Now let's look at we're going to skip number 4 for the second. We're going to look at how to name a polyatomic ion. So let's say that I have aluminum, and we're just going to go with sulfate. What was aluminum's oxidation number? +3. Okay, we got that from our periodic table here. Aluminum's oxidation number is +3, so that's our cation. We're going to go here, +3. If you look in your chart, what is sulfate's oxidation number? It's at the bottom of the middle column. It's a -2. All right, so I'm going to have a -2 here. Do those balance out?
No.
No. So my first step is I need to balance them out. So I've got +3. I need a -2 here. I need a -2 here. So they balance out now, right? How many aluminums do I have?
2,
I have 2 aluminums. How many sulfates do I have?
3.
3. So I'm going to write that in parentheses, and I'm going to put a 3 right here. Okay? So now that formula is telling me I have 2 aluminum and I have 3 sulfate units. Okay? The way I name that with polyatomic ions, you just say aluminum sulfate. You just use the name of the polyatomic ion. There's no changing the ending. Okay? You're only changing the ending if it's this binary compound. You change the ending to IDE. But that's just chlorine by itself. Okay, I don't have a polyatomic ion here, I just have plain chlorine. So that's when you change the ending, when your anion is just one element, or a monoatomic ion. But when I get to these polyatomics, I just use the name that's here. Okay? Questions so far? We good? Okay. All right. The last thing I want to show you is back to reference to number 4. It says, per transition metals, indicate multiple oxidation numbers with Roman numerals. You know, I told you transition metals, they're wishy-washy, right? They just can't make up their mind what they want to be. Okay? So you kind of have to figure out what they are. So if I have a formula, let's say that I have, here's a binary compound, Fe2O3. So I have iron and I have oxygen. Now I know oxygen's oxidation number. Okay, oxygen's oxidation number is -2. So I'm going to go back here. I know that it is -2. And how many oxygens do I have?
3.
I have 3 of them. So -2, -2, -2. So my negative charge here overall is -6. What does that mean my positive charge overall has to be?
Positive 6.
It has to be +6. All right. How many iron atoms do I have?
2.
Have only 2. So what does my oxidation number for iron have to be if I only have 2?
3.
A +3. Okay. So the way I'm going to name that is I have to indicate in the name how the charge of the iron. So I'm going to write iron with Roman numerals. The Roman numeral for 1 is I. I'm just going to write 3 lines here, 3 capital I's. Iron 3 oxide. Because the oxidation number here is 3. Okay, we're going to do another one. Any questions on this? I know we have a little bit of confusion, that's why I want to do another one, but are there any specific questions I can answer that might help? No? All right, let's do copper sulfate. All right, so I've got copper. If you look, copper is a transition metal. And let's do sulfate over here. What is sulfate's oxidation number?
Negative
-2. How many sulfates do I have?
4 or 1.
Just have one sulfate, because that SO4, that whole unit is my sulfate. So I just have one sulfate. How many coppers do I have?
1.
One. So what does the charge on the copper have to be to balance out this -2?
Positive 2.
It has to be a +2. So the way I'd write that name, since that's a transition metal, you're only doing this way of naming if you've got transition metals. Okay? So only if you have a metal that's in the dip. Okay? You don't do this for all of them, only if that metal's in the dip. You're going to do copper 2, because my charge is +2, sulfate. Does that make sense?
Mm-hmm.
It takes some practice. Any questions? No? Yes.
Was that for the transition metal?
Yes, copper's a transition metal. So this is only for the transition metals, and from your notes, if you look at your notes, that's covering rule number 4. Per transition metals indicate multiple oxidation numbers for Roman numerals. Because you might have iron that has a +3 charge, or you might have iron that has a +2, but you really don't know until you look at what it's bonded with. Okay? All right.